Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi and great to everyone. Today our groups, which consist of me, Harith and Muhammad Husni, and my friend SYAZZANI will present about oxidations. So, for the table of content, there are 5 parts, which are introductions, animation flowchart, program source code, variable calculations, and conclusions. So for introductions, what should we know about oxidations? So first, oxidation is a thermal process that converts silicon on the wafer into silicon dioxide. The chemical reaction of silicon and oxygen usually already starts at room temperature, but stops after a very thin native oxide film. For an effective oxidation rate, the wafer must be settled to a furnace with oxygen and water wafer at elevated temperatures. So basically there are 2 types of oxidations, which are dry oxidation and wet oxidation. Basically dry oxidation, the oxygens come from gas. Meanwhile, wet oxidation, the oxygen is carried in the form of water vapor. The concentration of oxygen in water vapor is higher than in normal gas form. Thus, the oxidation rate is in wet oxidation is greater, but more costly. So next, the process of oxidation happens in furnace as the oxygen diffuse cross existing silicon dioxide layer and break with silicon. Silicon dioxide layer are used as high quality insulators or masks for ion implementations. The ability of silicon to form high quality silicon dioxide is an important reason why silicon is still dominating material in IC fabrication. So next, we go for the animation flowchart. Basically, in our video, we deliver a story explaining about oxidations. To explain about flowchart of our scratch video, I will divide it into 2 parts, which are the introduction part and variable part. So for the first part, this is introduction of oxidation process. So basically, in our video, we are narrative tell a story or brief explanation about oxidation itself. So you can see this flow of our animation in the video, which are explaining about the oxidations. So you can check the video for the details. So next is second part, which are the important part. That is the variable animations. Basically, in our video, we are emphasize 2 variables, which are time and temperature. So basically, for the time, these are the animation flowchart that involve. So in that video, you must click Z button to start the animation, so the graph will appear. So you must click on the clock repeatedly to continue. So if the graph is increasing as the time is increased, indicating that the thickness of the oxide layer is increasing by time, but the rate of oxidation is decreasing by time. So basically, after the graph, you can check there comes the time variable calculation. Basically, in this part, we are include the variable function. So to continue, you must press R button to insert the value. As you press the R button, you must press S button, then insert the expected oxide thickness, which are the variable that we will manipulate in this slide. So then press A button to continue to the calculation. So the time taken to complete the oxidation is calculated. Okay, to test the variable, you must insert different value of the expected oxide thickness. So you can determine there are the slightly change of time taken if you are change the oxide thickness. You must to doing so you must press R button to repeat the function. So if you don't want to proceed, you can just press the button arrow button to proceed to the next factor. So basically, this is a second part, which are related to the next variable, which are temperature. Okay, for the temperature, basically this is a simple one. When you press the arrow button, you will proceed to this variable. So basically, the oxide layer thickness is illustrated under 1 1000 degrees Celsius in fixed oxidation time. So in this variable, to change the variable, you must press neither up arrow or down arrow. Up arrow to increase the temperature, down arrow to decrease the temperature. So when you, for example, you press up arrow, so you can witness that the oxide layer thickness is increased under 1150 degrees Celsius in fixed oxidation time. If you press down arrow, that means the oxide layer thickness is decreased under 900 degrees Celsius in fixed oxidation time. You can rechange the variable by pressing neither down or up arrow to witness or to take the difference, to signify the difference between if you change the variable. So next is about program source code. Script program source code. For our program source code, we will only be focusing on our variable animations part, especially for time variable. If not, it will be long. So basically, for scratch source code is our main or background code. Is a main sprite 1, final formula sprite 10, backdrop sprite 2, sprite 3, sprite 4, sprite 5, sprite 6, sprite 7, sprite 8, sprite 9, sprite 10, and that's all for source code. So next is about variable calculation. Okay, this variable calculation that involved in our animations. These are, we will give a variable for the desired thickness, what the value that we want. For example, in this slide, we use 400 and 500. So we will try to evaluate what is the oxidation time that needed to complete the oxidation process. For example, for the 500, so it will take around 16 minutes to complete the oxidation process. For the 400, it will be faster, a bit faster, to 12 minutes, around 12 minutes to complete the oxidation process. Okay, so for the animation in scrap crash video, I will pass to my friend SYAZZANI to explain about it.
Now we proceed to the process of oxidation. Here we show you the animation using Scratch. The process is happen in the quartz tube with the silicon wafers was arranged at a quartz carrier. We set the temperature to the 1100 degrees Celsius. The process begins when the oxygen and hydrogen gas was delivered through the tube and moved to the silicon wafer. Then silicon wafer will react to the oxygen gas, produce silicon dioxide. For the hydrogen gas, it made the silicon dioxide less dense. The oxidation rate was influenced by the thickness of oxide layer. And we know every type of silicon wafer have their own oxide layer thickness. And now we insert the oxide thickness of silicon wafer. We assume the thickness of silicon wafer is 500, and we see what is the oxidation rate. Okay, we see the oxidation of silicon complete after about 16 minutes. And now, what will happen if we put the lower value of oxide layer thickness? Okay, wait. Okay, we put about 400. Okay, press A. Okay, the oxidation of silicon complete after 30 minutes. and we can say that the more thick of oxide layer, it takes more time to the silicon to complete the oxidation to oxygen gas to produce silicon dioxide.
Alright, thank you, SYAZZANI. Alright, for the conclusions, what I can conclude is oxidation is essential to the patterning of silicon for high temperature processing compared to photoresist that only can handle the process below than 150 degrees Celsius. Particle of silicon dioxide can be used for masking diffusions, etches, and other process up to temperature more than 1400 degrees Celsius. The extreme purity and perfection of silicon and silicon dioxide interface is the ultimate reason why silicon has been the number one semiconductor for microelectronics. So thank you. That's all from us. For details, crash animation related, you can find in the link that's provided. Okay, that's all from us. Thank you for watching.